We're here at the bottom of page 2 of the notes for section 1.3. And just a reminder from the book about rational numbers and decimals, how those, just some book definitions for you, reviewing what we've done and already talked about so far. Let's try these examples down here. List all numbers from the given set that are A, natural numbers, B, whole numbers, C, integers, D, rational numbers, E, irrational numbers, and F, real numbers. So it's our chance, given a collection of numbers now, identify which ones would fall in the category of naturals, and then wholes, integers. So there's going to be, and on down the list. And so there's going to be potentially more than one answer per letter here, as well as some numbers may show up in all kinds of different groups. Just like you're part of different groups, but you're the same person, these numbers can be part of different groups as well. Okay, so let's start with this first set, -5, and then you're going to try this set over here. So we've got -5. We've got negative 0.3 bar. The bar means that the 3 repeats forever. We have 0. We have radical 2, radical 4. So let's look at those just for a moment, especially these radicals here. We mentioned that the 3 repeats forever. The radical 2, this is a decimal that does not repeat. So by our definition, that one is going to be an irrational number. Okay, and because it's irrational, it's not going to fit into any of these other groups. Irrationals are a group that's separate from all of these. These nest inside of each other. The naturals are inside of the wholes. The wholes are then inside of the integers. The integers are then inside the rationals. But irrationals are a completely separate group. And the reals represent the whole thing, all of them together. All the rationals, integers, wholes, naturals, together with the irrationals, make the reals. Okay. Radical 4, let's just take a peek at here, because we know, or square root of 4, we know square root of 4 is equal to 2. So think of that as the value 2, so we're trying to make decisions on where they go. Okay, the natural numbers are the counting numbers. So as we would count along a group of objects, which of this set would be involved in that? Do not include 0. 0 is not a counting number. It doesn't tell you how many you have if you start counting at 1. 1 is where the counting numbers start. So the only counting number in this set is going to be that radical 4 because it's equal to 2. Okay? And then part B, the whole numbers. The whole numbers are the counting numbers plus 0. So you're going to have radical 4 again, and you're going to have 0, because you're going to have the whole numbers include the natural counting numbers and 0. So the 2 that are now from this set that apply to that definition are 0 and radical 4, which is equal to 2. Now let's look for the integers, which would be all the counting numbers plus 0 plus their opposites or their negatives. So as we look up here, that's not going to include the 0.3 that repeats, because we are not at the fractions and decimals yet. Definitely doesn't include irrational, but -5 does apply. It's the negative of a counting number 5. Okay, so we're going to go ahead and have that radical 4. We're going to go ahead and have the 0 in this group called integers, and then we're also going to add in -5. Okay, so 3 of these values inside this set could be called integers. Let's look for rational numbers. Now, rational numbers are all the counting, all the wholes, all the integers, plus anything that can be written with a decimal that ends or repeats. Okay, so we've got 3 of the 5 represented in integers. Those will definitely show up again, because they're integers, and all integers are also rationals. Radical 4 is 2 over 1. There it is in rational form, or 2.0. 0 is 0.0. It has an ending decimal form. -5 is -5 over 1, or -5.0. But what else can fit in the rationals here? Our other 2 choices are -0.3 that repeats, or radical 2 where the decimal does not repeat. Rational has to have an ending or repeating decimal. So -0.3 is the one with the bar, sorry. Sorry, I don't like it when I make mistakes in pen. -0.3 with the repeat gets added to this set. Okay, so 4 out of this set could be called rational numbers. And irrational numbers, then again, are anything that is not rational. So in this case, 4 out of the 5 are rational. The only one that's not is this radical 2. Okay? So you've got your rationals and irrational are a separate set. And then finally, which of these are real numbers? Well, real numbers are all the rationals plus the irrationals. So we have 4 rationals, 1 irrational. The whole set has real numbers. And we won't throw in imaginaries. That would be the, like rationals have irrationals, the opposite. There's real and imaginary. We'll talk about imaginary numbers in Math 95 in detail. We hint at it at Math 65, but you don't have to worry about that now. So reals is everything we see here. So it's going to be our radical 4, it's going to be our radical 2, it's going to be our 0, our negative 5, and our negative 0.3 with the bar. So it's this whole set. I probably should have just written it in order like they gave it to us. But it's the reals are the rationals and the irrationals together. Okay? Alright, I'll give you a chance to copy that down and then think through number 34. Try it on your own. See if you can identify in this set what's the naturals, wholes, integers, rationals, irrationals, and reals. Then pause it and finish that up on your own. Come back for the answer. Okay, you should come up with the natural numbers would be radical 49 because that equals 7. The whole numbers are going to be 0 and radical 49. The integers are going to be negative 7, 0, radical 49. The rationals are going to be negative 7, negative 0.6 with the bar, 0, and radical 49. And then finally the irrational, the only irrational in the group is radical 50. And the real numbers would be the entire set, negative 7, negative 0.6 with a bar, 0, radical 49, and radical 50. Okay. We will see you at page 4.